Everyone wants to talk about artificial intelligence. Almost nobody wants to talk about what actually makes it fail. Because once you do, a lot of advanced systems stop looking impressive. You can have the smartest algorithm on earth, but if it's bolted to the wrong payload, integrated wrong, powered wrong, it doesn't just fail, it lies. And in real missions, lies get people hurt. Welcome to the Swarm News. This is where veterans and engineers talk about defensive tech the way it actually works, not the way it gets pitched. If your system looks smart on a slide, but collapses under real conditions, we're not impressed. I'm Joshua Hill.
And I'm Vincent Lewis. And first, we want to say thank you for coming back. If this is not your first time, appreciate you following, liking, and coming to our show and watching this again. And also, just to give a little bit of update today on some of the stuff for DARPA Challenge. I know we've been kind of putting out a little bit of information. It seems like now it is live. The DARPA Challenge has finally went to a place to where they are taking submissions. Started January 5th. Also, there's a slight change for those who are probably entering that you're probably tracking, but those who don't, there's DARPA is working to put in a waiver with the FAA so that they can meet the needs of being able to fly an aircraft that's over 54 pounds or meeting over the 55-pound weight limit. So right now, all those guys who are actually flying, actually creating system would be outside of their regulation limits by basically flying anything over 55 pounds, and they would be illegally flying. So DARPA is actually working to put a blanket waiver for all those who are doing it. Also, there's been some slight changes on the FCC publication notices for the cover list, and those notifications basically will be put in notes and below so you can be able to go to and see for yourself what they did. They're basically not saying that they're covering all items on drone and stuff. So they know they don't cover everything, but they're trying to let everybody know that there are some things that they will be making some changes to. But keep you posted and what's going on. We will make sure that we put a note in the notes so that you can be able to go to and see these things for yourself and be up to date on it. That being said, Josh, back to you.
Yeah, so here's the core problem. Most defensive tech companies treat AI like magic dust. They sprinkle it on a bad system and call it next gen and hope that nobody asks any of the hard questions. That works in pitch decks. It fails immediately in the field. AI doesn't exist in a vacuum. It lives downstream of sensors, payloads, power, comms, and trust. If those are wrong, AI doesn't make failure better. It makes failure faster.
And from the engineering side, this can be controversial. Conformance has its limitations, and AI is adding performance pluses, but at the same time is adding limitations to what it can do. With all this comes a requirement for more power because now you have alternate systems being put onto an aircraft that didn't have it, whereas you just had your regular flight controller doing all your work. Now you may have a coprocessor, in this case, like Raspberry Pi or Arduino, helping to support the aircraft doing what it needs and communicating back and forth. Sensors, the quality of them needs to be at a little bit higher of a rate of resolution or quality. So taking something like millimeter wave sensors, such as like this, or taking a AI camera from a Raspberry Pi that actually can do its own work of understanding and seeing what it sees, or even figuring out placement. Typically when you have a regular FPV camera, you can place it a little bit easier. But when you take a camera like this that has to be attached to your Raspberry Pi, as you can see, that's a little bit harder to kind of coordinate to be able to be functional as a standalone camera or just a camera by itself. Because normally you just have wires, and a regular wire is good, but when you got ribbon cable, it's a little different. On top of timing, You got to have all these things in sync with each other to work with what they need to do as a unit and not as a individual system. And then the data integration, you got to be able to now take all that data that's coming out of that system and make it work all together. And that is a lot that needs to be put into play versus just building a small little race drone that basically just has motors, a flight controller, and your favorite receiver and transmitter, and or say RFD in this case for like a Pixel, and just going out and flying. It takes a little bit more time and effort. If the payload isn't designed with AI in mind, you're tending to feed noise and other very problematic problems into a very confident, typically known system or model.
Yeah, I mean, this is kind of where I think the startups get everything completely backwards. They design the AI first and then ask, what sensor should we hang on it? That's not innovation, that's negligence. I mean, in real operations, payloads drive everything. When I was working SIGINT, the question was never, hey, what algorithm do we want to run? It was, hey, what's the signal we're going after? Where are we collecting the signal from? What are the conditions that the sensor or the information is coming from? How far away is it? AI should be coming after that. If you didn't start with the signal, you've already failed.
Yeah. And when you're looking at it, the payloads defines what your signal is going to be, the noise in it, your resolution, latency, your field of view for like the camera, spectral coverage. Like when you add in, say, what you're having to communicate and send the signal back through, significant change. Granted, right now, compared to what it was even 3 or 4 years ago with these transmitters and receivers, you have a very big capability that you didn't have before, but you're also putting a lot more into the air that you now have to track and figure out if it's working and if your redundancies actually work well and testing them, not even coming up with a test, but testing them to make sure that they work like they're supposed to. And ignoring these constraints and your model's learning patterns it may not survive that in reality.
Yeah, I mean, and let's get into the what operators hate, especially as an operator myself. That's just some of the stuff I hated is when AI systems that sounded confident and they were wrong. In the field, confidence doesn't save you, accuracy does. The wrong answer delivered fast is worse than no answer at all. That's how missions get derailed. That's how operations stop turning and trusting systems. I mean, back when I was doing missions and we were using different sensors to do the collection, we still always used a actual operator to validate the data coming in for the calls that were going out because you can't trust everything that's going in because sometimes there are minor the collection system was just slightly off, but it was off enough that there was a variable that it was still should have been called something else that was could have been dangerous to other aircraft that we needed to make call outs for. So this trusting the systems is very difficult. Like when you've got that operator mindset, like you want to know that what you're getting is right.
Yeah, I agree. And imagine, you know, having a small aircraft. Granted, this thing may not be that big, but if this is flying 70, 80 miles an hour and you're flying it at something or someone and it isn't, and it's running by a camera or running by its own autonomy, that could be a flying freaking weapon or a softball. It's like imagine a softball coming dead at your head at 100 miles an hour, how much danger that could be. And you ain't got a helmet like in baseball or in softball. So having these systems, having the, alignment with them and the sensors calibrated to what's necessary for the flight controller and the coprocessor or whatever you have on there to work as a team is very critical. And misaligning these can cause a lot of issues, not only with flight, but with your data that you're trying to get back. Like we were saying before, the thermal drifting in the cameras where you're expecting the camera to put out something and you see it in a different way. And it's because you didn't calibrate it with your prior to it going up to flight and doing it on the ground. or it's oversaturated with contrast between black and white and not getting it core calibrated with that, desynced in your signals, as you know, say your transmitter fidelity, if you didn't have your throttles properly calibrated and now you're going up, you may lose some of that throttle band that you normally would have. Weather also is always the impact that most people don't really see, but weather can impact you on how much you can actually do in some areas. Like if you're in a hot environment, you're going to have to take consideration that your battery power may be gone or going down quicker than normal. Or if it's cold, that could be an effect that helps you because it now makes your batteries work a little bit better. But if you don't warm them up prior and keep them warm before they go into flight, it could also cause the same thing as if it was hot.
Yeah.
You have effects that help and hurt with all these. It's just knowing them. And if you don't build, your health awareness into your payload stack and keep the AI in a place to where it can make decisions, it can put in bad inputs and bad decisions for you that may not be what you want. So that's how you get fast and proper answers over wrong answers, if I say that properly.
Yeah. So, I mean, and here's the part that people just don't like to admit. Payload isn't just a camera or a receiver. It's the mounting, the way that it's mounted, vibration isolation, power stability, thermal management, comms bandwidth, your timing. If any of those things are off, the data lies. And AI has no idea it's being lied to. It just keeps deciding confidently, quickly, and wrong.
Yeah. And like you said, vibration, I've seen several times where vibrations in a flight controller have caused multiple issues over a long period of time. And you wouldn't think it would be that big of a deal, but when the algorithm is, or that payload loop or pit loop is trying to work out what it needs to do, that vibration causes it to have issues that it may not be able to come up with a solution well. So just something as simple as that can cause you a problem. Whereas taking, now, not saying to put it on here, but in other words, if you take something as simple as this, where you put a flight controller, say in this area, and you have it on a something with gummies, we would call them, and it's just taking away some of that vibration, it allows that flight controller the capability of now keeping its sensitivity down and allow it to work the way it needs to. And that right there is just a simple thing. AI is looking at, hey, I'm trying to identify a person, a thing, or a car, or a building. And when it's trying to do all that, if it has a lot of vibrations or jitters, imagine your eye trying to recognize something from the ground from even 200 feet up and how you're trying to understand something. Cameras for AI can figure it out, but imagine if it was stabilized and it had that trueness on it that it didn't have to worry about it. Those would be helpful. Everybody would, I think, would agree with that,
Yeah.
that taking those into consideration when you're doing it before you go into your first flights can eliminate you from having to do something over or even lose an aircraft.
Yep.
Mechanical interfaces, electrical noise, your clock syncs for your GPSs, making sure that you have the proper firmware update and you're on the right constellation of systems between using your GPS for US versus using one for like say Russia or China or even the EU, those different areas where you could be at. And then edge versus backhaul, working with whatever you're going to use for your protocols for your communication or not communication protocols
Priority.
for your computers being functional for within them. And also sync because
Right.
say 5G to a 2.4 gigahertz signal to G signals to like 900 megahertz, stuff like that, where you can send higher packet rates with a 900 and it's may not be as quick, but you can at least get more data versus you're sending at 2.4 a lot faster, quicker response time, but not as much data. You know, considering those all in a place. Whereas if you use 5G, you have a kind of best of both worlds, but you also have now a higher power consumption. Your AI needs the cloud in order to compute. So you got to figure out what you're going to need the most that's going to help you do what you need to. But the commas and degrades that happens, is that really something that you need? That, I gotta put it, your degrading system being able to be functioning is more important than it being perfect. It needs to be able to function well no matter what's going on. And that's where, some demos die.
Yeah. I mean, everyone wants the edge with AI, but almost nobody designs for it properly. Edge AI isn't magic, it's a punishment test. Heat, power limits, dropped comms, degraded GPS. If your system only works when everything is perfect, it's not autonomous, it's fragile.
Yeah. And with edge demands, efficiency models, predictable data rates, thermal headroom, the stable power, you want those to be at a place to where it's not a concern to the system. You can, bolt on AI to a payload, but that doesn't mean that it's going to be something that's going to work well. You need to make sure that it all syncs as a single unit and works together, and never design a support computer that isn't able to work as we can as a group, and as a single team in this case, and that's how systems fail silently.
So let's ground this. Real missions where payload plus AI integration matters. Counter UAS in cluster, ISR prioritization under bandwidth limits, SIGINT triage in defense spectrum, autonomous logistics validation. In all of these, AI doesn't replace judgment, it filters chaos.
Yeah. And that technically means sensors infusion, declassification, and helps to make confidence within the system and explainability between them all. You know, these systems become less degraded between the parts being able to function where they can know their own protocols and your way of writing whatever your scripts are and your coding then comes into, or not coding, how I put it, what you basically write for your base program will now allow that program to work more efficient when it knows what it has to do without having to have other added in problems. You know, adding in, like you're saying, the chaos between filtering out things, but making it to where you eliminate as many issues you can as you go will, common sense wise, make your system work well. But if you don't think about it ahead of time, this may be something that can go by the wayside and basically cost you time and money over time. And it'll tell you, I'll tell you this, what you see may not be a common sense factor for a lot, but in this case, some people may not think about these things, as they're building their systems. You know, it may give them a sense of falsity when you're really thinking about it of, I know what I'm doing, I know how this is going, and I know what I need to. But if you don't take it in consideration, it gives you a false sense of safety when you don't really look at it as a whole.
Yeah. So let's talk about why startups fail, man. Like most startups chase AI because they think it unlocks funding, but the DoD doesn't fund intelligence; it funds capabilities. Capability survives bad days, bad data, and bad conditions. If your system needs perfection, it doesn't belong in defense. What works is boring and effective. Start with the mission, design the payload for reality, integrate power, comms, and mounting correctly, and then add your AI where it actually helps the user.
Yeah. And then design the payloads with AI in mind so that it can validate the data that you want and with the quality in mind first. And then you can pretty much then do your test integration from those conditions after you basically know what you're expecting and you have a quality output. And this helps you assure that your failures are lessened and will not happen as very often, if at all. And then it brings down your situation of having degraded systems and helps to build in resilience and makes your system work well.
Yeah. So AI doesn't save bad payloads. Good payload integration makes AI honest. Defense tech isn't about being smart, it's about being right when everything else is breaking.
Yeah, payloads, power, data, and computers are one system. Design them separately and they won't fail. They'll work together as a harmonious unit versus just something individually as a piecemeal system put together just because you wanted to make something work.
Yep. If this episode made you rethink how AI actually fits into defense systems, send this to someone building smart technology without asking any hard questions. That's where survivability lives. If this perspective matches how you think, subscribe, like, follow, all that fun stuff. This is what we do every week.